Good day, learners. Welcome to Physical Sciences lesson. My name is Aminim Kize. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Right, learners, today we are going to focus on mechanics. The knowledge area is mechanics, and then under mechanics we are going to focus on Newton's laws and application. Right, under Newton's laws, according to your examination guidelines, this is what you need to know. When it comes to your Newton's laws, one, you must be able to state Newton's first law of motion in words, which is defined as a body will remain in its state of rest or motion at a constant velocity unless a non-zero resultant force or net force acts on it. And then also define inertia as the resistance of an object to any change in its state of motion. And then discuss why it is important to wear seat belts using Newton's first law of motion, and also state Newton's second law of motion as the resultant or the net force acts on an object. The object will accelerate in the direction of the net force, and acceleration is directly proportional to the force and inversely proportional to what? To the mass of an object, right? So, and also you must be able to draw force diagrams and free body diagrams for objects that are in equilibrium or accelerating. Okay, again, under Newton's laws, you must be able to solve problems including a single object moving in a horizontal plane with or without friction, moving on an inclined plane with or without friction, moving in a vertical plane, and also two body systems joined by a light inextensible string, both on a flat plane with or without friction, one in a horizontal plane with or without friction, and the second hanging vertically from a string over a frictionless pulley, both on the inclined plane with or without friction, both hanging vertically from a string over a frictionless pulley. Right, and also you must be able to state Newton's third law, and also know how to identify the action-reaction pairs. And also the last one, it will be obvious on what on Newton's law of universal gravitation. But today, learners, we are not going to focus on Newton's third and Newton's law of universal gravitation. Our focus today is just Newton's first law and Newton's second law. Actually, the application of Newton's first law and Newton's second law. It's what we are going to focus on today. One, what is important, learners, when it comes to these two laws, learners, make sure that you are able to state these laws correctly, right, according to your examination guidelines. In most cases, I just want us to go back. In most cases, when learners define Newton's first law, they will only, say the body will remain in its state of rest unless a non-zero resultant force acts on it. If you are going to do that, learners, I'm telling you, right now, you must know that we are not going to get marks, right? So when we mark, this law, it's either 2 marks or 0. So it's very, very important to include everything as it is, as you can see on your on your examination guidelines, right? So you need to make sure that you state the law as it is. So what you see, so you need to produce what you have on your examination guideline. So it is stated as what a body will remain in its state of rest or motion at a constant velocity unless a non-zero resultant force acts on it. So this is how we have to state Newton's first law. So please do not omit any key words here. If you are going to do that, you are going to get 0 out of 2 marks. All right. Then same with your Newton's second law. Newton's second law. In most cases, this law is marked independently, right? But even if it's marked independently, please make sure that you state it correctly. So, right? It is stated as when a resultant or net force acts on an object, the object will accelerate in the direction of the force at an acceleration that is directly proportional to the force and inversely proportional to the mass of an object, right? So you can see there they said when a resultant or net. So you need to choose. You can't write both. Remember, you are not writing a memo, okay? So it's either you'll choose resultant or net force. So when a resultant force or when a net force acts on an object, the object will accelerate in the direction of the force with an acceleration that is directly proportional to the force and inversely proportional to the mass. So please, learners, be careful again when it comes to this part of acceleration. It is the acceleration that is directly proportional to the force, not the net force. All right. So in most cases, we'll find learners using F net, equals to what? Yes, ma, right? Then they'll say net force directly proportional to acceleration and inversely proportional to mass. So that is not actually correct, okay? So we need to make sure that we state it correctly. So it is acceleration that is directly proportional to the force. It's not the net force or the force that is directly proportional to the acceleration and inversely proportional to what? To the mass. So please, learners, it's about acceleration. It is the acceleration that is directly proportional to what? To the force, and acceleration is inversely proportional to what? To the mass. So please, let's not omit the key weights there also when it comes to stating Newton's second law. Otherwise, if you don't include all the necessary weights there, you need to understand that you are not going to get marks. So please, we cannot lose marks when it comes to definition. So you have your examination guidelines, so make sure that you produce what you see, or on your examination guidelines, right? Then again, another thing that we need to understand, maybe again when it comes to Newton, a first law, right? It's either an object is stationary, at rest, or forces are at equilibrium, or an object is moving at a constant velocity. So when you read a statement and then they are talking about an object that is at rest, an object that is stationary, or an object, that is moving at a constant velocity or constant speed, right? So please understand that question is about application of Newton's first law, right? But when an object accelerates, so if there's change in what now? In velocity, then it means that the object is accelerating. So if the object is accelerating, it means that is going to be application of what? Of Newton's second law. So it's very, very important. So when you read a statement, okay, you must be able to tell which law is this, right? So that is also very, very important, learners. So then let's check other important documents that you need when you're dealing with Newton's laws and application. It's your data sheet, right? So I believe all of you have your data sheet in your exercise books. If you don't have it, it is there on your examination guidelines also. You just need that page and then you paste it on your books, right? So that, remember, it's nice when it comes to physics. You don't have to memorize, the equations or the formulae, all right? So the formulae or they are on your data sheet. So the only thing that we want from you is to know when to use which equation, all right? So for example, here when you look at your data sheet, we have this equation, which is your F net equals to ma. So this is obvious, the application of Newton's second law, right? So Newton's second law, acceleration being directly proportional to the what? To the force, and inversely proportional to what? To the mass. So it's F net equals to what? ma. So this equation, we'll use it obviously if an object is accelerating, right? But if an object is moving at a constant velocity or constant speed, or forces are being at equilibrium, or the object is at rest, your F net, even if you can say F net equals to ma, right? But your F net will be equals to what? 0. For an object that is stationary, or for an object that is moving at a constant speed or constant what? Velocity. Another equations here, it's your Fx max, the maximum static friction. You must know what is maximum static friction. It is given by what? Fx max equals to mu s, which is the coefficient of static friction multiplied by the normal force. You must know what is normal force also, all right? Remember, it is defined as what? The force that the surface exerts on an object which is in contact with, and it acts perpendicular to what? To the surface. And then this is your Fk. So your Fk is given by mu Kn, where Fk is the kinetic frictional force, and you should know what is kinetic frictional force, which is the force that opposes the motion of a moving object relative to the surface. And then this is mu k, which is the coefficient of kinetic friction, and then you multiply that by the normal force, all right? So and also calculating weight. So we'll deal more with these ones, these equations next week when we are dealing with what? Newton's law of universal what? Gravitation. So these are important, formulae when it comes to your Newton's laws, especially application of Newton's first law and also Newton's what? Second law, right? So it's important, learners, make sure that you don't lose marks. When the question says state in words the Newton's first law of motion, or Newton's second law of motion, please state it correctly. We can't afford to lose marks, you know, when it comes to definitions. All right. Then again, copying what the wrong formula, you cannot do that. There's no need learners to memorize the formula, so, or the formula, right? So you will find some learners when they are calculating what for example acceleration, and they're supposed to use this equation, right? F net equals to ma. They will say F equals to ma. According to this formula, remember, it's not F, right? It is F net, which is the sum of what? Of the forces. So those are the important things. So we cannot lose marks, you know, when it comes to copying. Just learn to copy the correct equation from what? From the data sheet. All right. So let's look at also the multiple choice questions. Remember the structure of our question paper, whether it is paper 1, which is your physics, or paper 2, which is your chemistry. The question 1, the first 10 questions, right? So question 1, 1.1 to 1.10, it's multiple choice questions. So we must actually get used to, you know, answering, you know, multiple choice questions correctly. Okay, so for you again to be able to answer multiple choice questions correctly, you must know your content. All right, so if you are dealing with Newton's laws, you know, you must be able, reading from the statement, you must be able to tell which law is this. Is it the Newton first law? Is it the Newton second law? If it's the Newton second law, for example, which equation am I supposed to use? You know, right? So those are the things that are very, very important, okay, when you are dealing with multiple choice questions, right? So let's look at this question, a net force, right? So here they're talking about the net force. All of us, we know by now what is net force. Net force is also the resultant force, which is the sum of the forces, you know, acting on what? On an object. Then the net force F, all right, is applied on an object of mass m and causes an acceleration of a meters per second squared. All right, so you can tell that, okay, here I'm dealing with which law? Newton's second law of motion. All right, so when the net force F on all right, when the net force F on the same object is doubled, right, the resulting acceleration in meters per second squared will be. So we need to find out what will happen now if the net force now is being what? Doubled. All right. So first thing here, okay, they are talking about the net force. There is mass, there is acceleration. So for the original what? Object, F net equals to what? ma. All right. So that is, let's just say this is object what? Object 1. All right. And remember, our F net is F, our M is M, our acceleration is what? Is A. Okay? This is what is given, right? Then object 2, what is happening here? Okay? When the net force F on the same, okay, on the same what now? Is the same object, right? So which means that if it's the same object, it means that the mass is kept what? Constant. So they want us to find the acceleration when now the net force is what? Is doubled. Okay, so I'm having what here? F net. So it's the same object. F net equals to what? ma. So F net, F now is being what? Doubled. So I'm having twice F there. Mass is still the mass, right? Then I want to find what here? The acceleration. Okay, so I need to find what here? The acceleration. So the force now is what? Is doubled. Then we need to find what? The acceleration. So how are we going to get that? So remember, one of the things that you can do without using this method that I'm using here, you know already the relationship between what? Between acceleration and the force, right? The relationship between acceleration and the force from Newton's second law, acceleration is directly proportional to what? To the force, all right? So directly proportional, it means that if, for example, in this case, you can see that F is being doubled, all right? So F is increased by the factor of 2. We are expecting also A to increase by the factor of 2. So it's another thing that we can use, all right? So we are expecting A also to increase by what? By the factor of what? Of 2. So your answer, you can say there, it's what? It's C. Let me use a different color here. You can say your answer is what? It's C. Okay? So using the law, Newton's second law, acceleration, remember, is directly proportional to the force. Okay? So if F is doubled, we are expecting A also to be what? To be doubled. Okay. Then another thing that you can do. Remember here we are looking for what? For acceleration. Okay? Then acceleration here, I'm making A the subject of the formula, right? So acceleration will be what here? Will be F over what? Over M. Okay? Then for this one, A will be twice F over what? Over M. Okay? Then the new acceleration will be what? Okay? A equals to twice. What is F over M? F over M is what? It's acceleration. All right? So it will be what here? Twice. What is F over M? F over M is what? It's A. Which means that the new acceleration will be what? Will be twice A. So this is another method that you can use, right? So what is your A initial? Is A equals to F over M. But now, in the same object, now the force is being doubled, okay? So where there is F now, I'll just say what? Twice F. Then I need also to make A the subject of the formula. So making A the subject of the formula, in this case, will be twice F over M. But what is F over M according to this? F over M is what? Is A. So where there is F over M, I've substituted by what? By A. That is why my A there will be what? Will be twice A. So this is how actually learners you need to answer the multiple choice question. So obviously if you don't know what is happening when it comes to Newton's second law, or if you can even identify that this question is about Newton's second law, then it will be difficult for you to get this question correct. Okay, then let's look at the second one. The second one, a lawnmower is pushed across the ground with a force of F at an angle theta with the horizontal, and then the weight here is W, right? So they want, what is it that they're looking for here? Let's check. The normal force, right? So they're looking for what here? The normal force, right? So what is happening here? I'm trying to draw what here? A force diagram, right? So already, this is already a force diagram, right? Or let me just draw a free body diagram, right? Remember, with a free body diagram, object is represented by the dot. So there's normal force there, all right? We have weight, okay? And then we have weight there. And then what else do we have here? Is the force. We cannot draw it like this because it's a free body diagram. Forces, they must point away from the dot. So that force that is being applied, okay? So this is what we have. So they didn't talk about frictional force here. So there's no way that we can include what? Frictional force there. So they are looking for what here? The normal force. So learners, you can see that this force is applied at what? At an angle. So if a force is applied at an angle, we need to resolve that force into its what? Component. So we are resolving. I'm having the normal force, all right? Then I'm still having weight there. Then there will be what here? Your Fy, which is acting downwards, and your Fx, which is acting to the right. Okay? So it's the normal force. Then I've resolved that force. Since it is applied at an angle, I need to resolve it into its what components, which is your Fy and Fx, right? So the normal force. So this object moves horizontal. Ne? So the forces that are acting vertical, or the forces that are perpendicular to the plane, they must give you, their net force will be what? It will be 0 newtons, right? So it means that here I will say, okay, F net for the vertical forces will be normal force minus weight minus what? Fy. Why minus weight minus Fy? They're acting the opposite what direction? So I'm making, N being positive, or I'm taking upwards as what? As positive. So downwards will be what? Will be negative. But the forces that are perpendicular to the surface in this case, right? Their net force is what? Is 0. So I can say, okay, this is going to be 0 equals to N minus weight minus vertical component. Okay? Then I'm making n the subset of the formula, which is what I'm looking for, right? So my n will be, right, weight plus what? Fy. Okay? Why am I saying weight plus Fy? All right? So it will be, if I transpose this to this side, weight, remember this side is negative, so on the other side will be positive. Same with what? The vertical component, right? So this will be what? Mg, this is how we calculate weight, plus what? How do we calculate Fy? It is given by F what? Sine theta. So this is what we are expecting here. This is what we are expecting, right? So it's weight plus Fy, which is the same as Mg plus F sine theta. So let's check which answer is correct, okay? It cannot be A, right? Again, it cannot be what? C. It can also not be what? B, D. So the correct answer here is what? It's weight plus what? Plus Fy, which is what we got. It's weight plus Fy, right? So here it's about what? The forces here, all right? The forces. If a force is applied at an angle, we need to make sure that the force, we resolve that force into its what? Components. Right, let's look at this one. Which one of the following vector diagrams represents three forces acting on an object simultaneously while the object moves at a constant what? Velocity. Okay, constant velocity. What comes to your mind? If we say the object is moving at a constant velocity, my F net will be what there? 0 newtons. Okay, so my F net, let me write it this side. My F net will be what? 0 newtons. My acceleration will be 0 meters per second what? Squared. Because an object is moving at a constant what? Velocity. So this is application of which law? Newton first law. All right. So if this is application of Newton's first law, it means that F net is equal to what? 0. So which vector diagram shows 0 net force? All right? Which diagram shows 0 net force? If you can check here, they've used, we did talk about finding the resultant force by scale drawing, where we used tail-to-tail method and also what tail-to-head method. So the forces here that are drawn, you know, what tail-to-head. All right. So if you check the first one, okay, you check the first one. You have, let's say this is your F1, this is your F2, and then this is what? Your F what? Your F3. Okay. So let's do the same here. F1, F2, F3. So I want to show you something. F1 is this one. F2, then this one is F3, and then this is going to be what? F1, F2, this is going to be what? F3, right? So what are we expecting here? If an object is moving at a constant velocity, net force is equal to what? 0 newtons. Acceleration is equal to what? 0 newtons. So this is application of which law? Newton's first law, right? So if F net is equal to 0 newtons, we are expecting what type of a diagram? A closed vector what? Diagram. Okay, so here we're expecting what? A closed vector diagram, because this object is moving at a constant what? Velocity. F net is equal to what? 0 newtons. So we're expecting what? A closed vector diagram. If it's a closed vector diagram, right, we need to know, right, that F net is equal to what? 0 newtons. So but when you look at your B, right, there is a resultant there. Okay, actually, let's check. We can see the forces are drawn what? Head to head here, right? So it's head to head. So if it's like this, if you can try to complete this, right? If you can try to complete this, the diagram, the parallelogram using tail to what? Tail, then you have your F1 this side, you have your what? Your F2 there, right? So your resultant should be what? This diagonal, right? So there is a resultant here. This is not a closed vector what? Diagram. Okay, so there's a resultant here. Even when it comes to C, right, there is also what? A resultant. And then obviously, even when it comes to what? To D, there is also what? A resultant, which is greater than what? Greater than 0. So a diagram, a closed vector diagram here, it's option A, right? This is a closed vector diagram. Check. right? There is no resultant there. So this is the closed what? Vector diagram. So what are we expecting if an object is moving at a constant velocity in terms of the vector diagrams? We're expecting what? A closed vector what? Diagram. Okay. So A is a closed vector diagram. So the correct answer there for 1.3 will be what? A. Right? Then let's look at 1.4. A block with a mass of 4 kilograms is pulled upwards along a frictionless slope, right? So there's no friction, inclined at an angle of theta with a force F as shown in the sketch below, right? So this is an incline, right? And in an inclined plane, you need to be careful, right? That your weight, it's not acting perpendicular, right? So the weight here, it's not acting perpendicular to that plane or to that inclined plane. So the weight here is acting at an angle, right? The weight, or Fg in this case, is acting at what? At an angle. So if a force is it's acting at an angle, what do? We resolve that force into its what? Components. So that's the reason why we need, when it comes to an inclined plane, we need to resolve weight into its what? Components, because weight here is not acting perpendicular to the plane, but it is acting at an angle. So if it's acting at an angle, we resolve that force into its what? Components. So the components will be your Fg parallel and the Fg what? Perpendicular, right? So first thing that we need to do here, we can draw a free body diagram. This is our incline. So you have your what there? Your normal force, and then there's your Fg there. There's a force that is applied, right? And then there's no friction, okay? Then we can resolve weight or Fg into its components. Why are we doing that? Because weight in this case is not acting perpendicular. It is acting at what? At an angle. So if a force it acts at an angle, we resolve that force into its what? Component. So let's resolve. So I will have what here? The normal force, and it goes together with what? With the Fg what? Perpendicular. Then this side, it will be what? Fg what? Parallel. And then there will be what here? Force applied. Okay, so what are they looking for here? Which one of the following equations can be used to calculate the magnitude of the number? So even here is the normal what? Normal force, right? So this object moves parallel to the incline, right? It's not moving perpendicular to the incline. So which means that the forces that are perpendicular to the incline, right? Their net force should be what? 0 newtons, right? So here I'm having what? F net for the perpendicular forces equals to 0. And then those perpendicular forces is N minus what? Fg perpendicular. This is equals to what? 0. So which means that here N is equals to what? Fg what? Perpendicular. And how do we calculate Fg perpendicular? Our Fg perpendicular is given by what? Mg what? Cos theta, not sine. Sine is for parallel component of weight. So it's Mg what? Cos theta. So if it's Mg cos theta, all right? If it's Mg cos theta, so its normal force equals to Fg perpendicular equals to what here? Mg cos what? Cos theta. So what is our M? In this case, we're given M as 4, and then this is going to be 9.8, and then cos what? Are we given the angle? No. So cos what? Cos theta. So this is what we want, okay? So let's check which option is that, where I'm having what? 4 times 9.8 cos theta. 4 times 9.8 cos what? Cos theta. What is wrong with option A? It is 4 times 9.8 sin theta. So for A, it is the magnitude of Fg what? Parallel, not Fg perpendicular, which is equal to the normal force, all right? So then, your A will be incorrect, and then let's look at B. B included also the parallel forces, so it cannot be. So we need to focus only on the perpendicular ones, right? So same with C. So this is incorrect. This is also incorrect because of this, all right? Even here, right? Then the correct option will be what? Will be D, which is 4 times 9.8 cos what? Cos theta. And please let us be careful when it comes to this thing of cos theta, sin theta. The cos theta, it's for Mg cos theta is for the Fg perpendicular, and then the Fg parallel, it will be what? Mg what? Sin theta. So please be careful when it comes to that. So I don't want learners to confuse fx with fg parallel. Fx is f, cos theta, but fg parallel is mg or fg, right? Sine theta. Same with the fy, the vertical component, right? And the fg perpendicular. Fy is f sine theta, but fg perpendicular is mg or fg cos theta. So please be careful when it comes to that. So let's not confuse those, okay? So, but if your maths it's correct, then I don't think you are going to have a problem here. So you must know your maths when it comes to this, because the mg sine theta, mg cos theta is not there on your formula sheet, right? So it's your maths that is going to give you that, okay? Then, right, we are done with that. So let's look at this question. This is a structured question, right? Remember, again, when it comes to the structure of the question paper, the first question is the multiple choice. So that is why I've also included the multiple choice questions here, so that you will have that skill of how to answer, the multiple choice questions. So let's look at the structured questions, which is from question 2 to 9 or to 10. Then it's about the structured questions. All right, so let's look at this one. A constant force F. Please be careful, learners. I know when learners see the word constant, some learners, they just become happy. It's not what is important here. Check what is constant, So they didn't say constant speed here, where you will say F net is equals to 0, acceleration will be 0, but they are talking about what the constant force. So that force is applied constantly, right, from A to B. All right, so if that object was pulled at an angle of 20 with a force of 5 newtons, so it will remain like that from A to B. So the force is applied constantly. All right, so please, I know when they see the word constant, they think, okay, we have arrived. F net is equal to 0. Remember, it will be 0 if you're talking of constant speed or constant velocity, object at rest, or forces that are being at equilibrium, or when it comes to a closed vector diagram, right? Then pulls, okay, constant force F pulls a 50 kilogram block. So you're given the mass of that block at a constant speed, right? At a constant speed. So you take note of that. Take note of that. At a constant speed. Then now we can say, okay, at a constant speed, then F net will be here? 0 newtons, because they've talked about the constant speed over a rough horizontal surface. Rough, okay, there's here? Friction. What type of friction? Kinetic, because this object is in in motion, right? Then the coefficient of kinetic friction UK between the block and the surface is 0.4. Okay, here I'm giving F net, right? I'm giving acceleration as 0 meters per second squared. You are also given Fk. You are not given the magnitude of Fk, but already you know that there's Fk, although you don't know the magnitude of 8. But I'm giving here? Mu k, which is equals to 0.4. Remember, the coefficient has no units. So this is what is given, right? So we are given this, okay? Then let's check the first question. Draw a labeled free body diagram showing all the forces acting on the block. You can see how many marks are we having there. There are 4. All right, if it's 4 marks, I'm expecting how many forces? 4 forces. Let's check if we'll be able to do that. All right, so I'm expecting 4 forces. So the forces will be, okay, free body diagram. I know Fg is always there, right? Fg is always there. Then I'm having again? The normal force. Right? What else am I having? The force that is applied at an angle, that force. And then you also have frictional force. Then the frictional force will oppose the motion. So how many forces am I having here? There are 4. So it's 1, 2, 3, 4. So 4 forces. Okay? So this is my free body diagram. This is the free body diagram. And again, be careful, learners, of the length of the arrows or the length of the forces. The magnitudes are not equal in this case, right? Remember, the force is applied at an angle. So in this case, my normal force will be, smaller than my Fg. So please be careful also when it comes to that. We did talk about this scenario before. So your normal force in this case will be equals to weight, weight minus Fy. You see? Then if normal force is weight minus Fy, it means that weight will be normal force plus Fy. I hope you can see, the difference between the two. So it means that your normal force will be, less than your what? Your Fg. Right. Those are some of the things that you need to be careful about. But the total number of forces here, there are 4. All right. Then let's go back and see what more are they looking for. State Newton's first law of motion in weights. Why are they saying we should state Newton's first law? This question is about which law? Newton first. Why am I saying Newton first? It's because an object is moving at a constant what? Velocity. So state Newton's first law of motion in what? In weights. So this is also very, very important. You cannot lose that 2 marks, right? So a body will remain in its state of rest or motion at a constant velocity unless a non-zero net force acts on it. That is how you have to state Newton's second law. Let me show you how they've marked it, right? Check here, okay? You can see 2 ticks, right? It's either 2 marks or 0. So please be careful when it comes to this. So it's 2 marks for everything. It's not 2 marks only for saying an object will remain in its state of rest or an object will move at a constant what velocity, but it's for everything. For you to get that 2 marks, you must give all of this and remember this is from your examination what guidelines. So this is very, very important, learners. Okay, then let's check another question here. So obviously the questions that follows, we are expecting that question to be the application of Newton's first law. They want us to calculate the magnitude of F. Okay, the magnitude of F. Right, so how are you going to calculate the magnitude of F? Let's check. Right, you can see now a force is applied at an angle, right? So when it comes to the issue of calculations now, we need to resolve that force into its what? Components. So I'm doing that. So I'm resolving this force into its components. So the components, they will be Fy and what here? And Fx. So why am I doing this? Remember, when you're dealing with questions, you must see all the horizontal forces and all the vertical what? The vertical forces, right? But what I know that here, okay, even if I can say F net is equal to ma, but my F net in this case, since an object is moving at a constant velocity, is equal to what? 0. All right? So which forces, right? Which forces am I going to focus on? It's the forces that are parallel to the surface. All right? And those forces is Fx and what? And Fk. It's Fx and Fk. This is equal to what? 0. So these are the horizontal what? Forces. Why am I focusing on horizontal forces? This object is moving horizontally, right? So let me focus on the horizontal forces. And how do we calculate Fx? Fx is given by what? F what? Cos theta. Am I given the magnitude of Fk? No, right? But I know that Fk is given by what? Mu k. Why mu k? I'm given the coefficient of kinetic friction. So it's mu k what? N. This is equals to what? 0. So I'm having F cos theta minus mu k. How do I calculate Fn here? Fn. How many vertical forces am I having here? It's the normal force, Fy and what? And Fg. Which means that in this case, my normal force will be weight minus what? Fg. So where there's n, I can substitute by what? Weight. How do we calculate weight? Is mg. So it's weight minus what? Fy. And how do we calculate Fy? Fy, remember, is given by what? F what? Sine theta. And then this is equals to what? 0. Okay, remember I'm looking for what? For F, ne? So you can do this. Or another thing that you can do, you can start by finding what? Fx, right? How can you get Fx? Okay, or maybe before that, let's just do this. Okay, let's continue this one. Then we'll check another method, right? What is F? So here I'm having what? F cos. What is the angle? Let's go back. The angle is 20, right? Yeah, it's 20 degrees. Okay, so F what? Cos 20 minus mu k is 0.4 times what is the mass? Let's check the mass. It's 50. Yeah? So the mass is 50 times 9.8, right? Minus F sine what? F sine what? 20 degrees. And this is equals to what? 0. So you can see here, how many unknowns am I having? There are only 2. Okay? So there are 2 unknowns. So not 2 unknowns, but there's only 1 unknown. Sorry about that. It's F, it's F. So I can find what? F here. In what? In newtons. So this is another thing that you can do. Okay? Or when it comes to this step, right? What you can do, start by finding Fx, right? So your Fx is equals to what here? From here, your Fx is equals to what here? Fk. Transpose Fk. Your Fk is negative. On the other side is what? It's negative. Okay? Then Fk is given by what? Mu kn, which is what? Mu k mg, because it should be weight minus Fy. So it's mg minus what? Fy, which is what? Mu k mg, okay, minus what? Is mu k mg minus Fy, which is going to be what here? F sine what? Sine theta. All right? So I think it's the same thing, because that is your what? Your Fx, which means that where there is your Fx, you can substitute by what? Where there is Fx, ne? You can substitute by what? Mu k mg minus what? F sine what? Sine theta. So this is what you can do here. But it started with what? F net equals to ma. But since an object is moving at a constant velocity, F net is equals to 0. How many horizontal forces did we have? It was our Fx and what? And our Fk. And how do we calculate Fx? It is F what? Cos theta. And then how do we calculate Fk? Is mu kn, right? And okay, if it's like that, already I'm having theta there, which is 20. So I've substituted by 20 there. I'm having mu k, which is what? 0.4. I'm having the mass. Where is this mg minus F sine theta coming from? Remember, your normal force in this case, it's weight minus what? Fy. So it's how to calculate weight. This is how we have to calculate weight minus what? Fy, which is F sine what? Sine theta. But remember, your maths also there must be correct. Ne? So you'll multiply this coefficient, right? So it will be what? 0.4 into 5 times 9.8 minus F sine 20 what? Sine 20 degrees. Okay? Then from there, find the magnitude of what? Of F. Okay? Find the magnitude of what? Of F. And the magnitude of F here, it's 182.156 what? Newtons. You can see they did the same thing here. They started with F net, all right? So A, which is equals to MA, and it's and then F net equals to MA. Your A, remember, is 0. So that is why here this side we're having what? 0 there, right? But the forces that we are dealing with here is the horizontal what? Forces, where it's your F cos 20 degrees, which is your Fx. So in this case, it's Fx minus what? Fk. You can see that, right? So it's F cos 20 degrees, which is your Fx, mu kn or Fn. And then your n, remember, is mg. So m is 50 times what? 9.8, which is what? 490. Minus what? Your what? Your Fy, which is what? Which is what? F what? Sine theta. So it's F sine what? Sine theta, which is what? F sine 20. And then F sine 20 gave us this, right? Then here we have the magnitude of what? Of F. But But what is important here, learners, is to make sure that you draw a correct free body diagram. And then from there, when you read the statement, you must be able to tell whether this is application of Newton's first law or Newton's what? Second law. So in this case, it was Newton's first law. All right. Then next question, let's check the last, I think it's the last one on this question. Oh, they are looking for what here? The normal force. Okay. Already we have the magnitude of the force now. So they're looking for what? The normal force. And the normal force, how are we going to get the normal force? The normal force, remember normal force here, N is given by what here? Weight minus what? Fy, which is mg minus what? Fy, which is f what? Sine what? Sine theta. So m 50 times 9.8 minus the magnitude that we got. Ne? So even if you got 500, it's still fine. There's what we call positive what? Marking. So continue with that answer, because at that moment you're not even sure whether it is right or wrong. So you continue with that answer. If, for example, for your f you got 500, you're going to substitute by 500, right? And then sine what? Sine 20 degrees. But what did you get here? It's 182. So it's 182.156 sine what? Sine 20 what? Degrees. Then we got the magnitude of what? Of the normal force in what? In newtons. And which is what here, what they got here, it's 428.07 what? Newtons. You can see here they're saying positive marking from the previous what? Question. So continue with that answer, then we'll get all the marks here. Yes, we'll lose the marks for the previous question, but for this question you must get all the marks because you've used the answer that you got before. All right. Then another question here, which is your 3.4. Let's check the 3.4 here. 3.4, they want the frictional force. Already we have the magnitude of the normal force. Ne? So the magnitude of the normal force, we got the magnitude of the normal force. Where is the magnitude of the normal force? This is the magnitude of what? Of the normal force, right? So we know that Fk is given by mu k what? N, right? What is our mu k? 0.4. What is the normal force? The normal force is 428.07. Then we'll get the magnitude of what? Of kinetic friction. Again, there must be a positive marking here. If your normal force, obvious, can you see that if the magnitude of F is wrong, right? You are not going to get the correct magnitude of what? Of N, which is the normal force. You're also not going to get the correct magnitude of what? Of Fk. But if you continue with those wrong answers from 3.3 then until up to this question, you will still get all the marks because it shows that you know what to do. It's unfortunate that you didn't get 3.3 correct. You understand that? Ne? So, but make sure that you don't leave questions unattended, and then even if you are not sure, as long as you are going to continue with those answers, you are going to get all the marks for the next questions, right? Or for the following questions, right? Then this is what they got here, 171.23 for the FK. Then let's check the last question, right? What they've done here. Now, I hope you can see the difference. Before it was pulled at an angle, right? Okay? So the same force, but now is pushed at what? At an angle. So what is going to change here, right? One, the angle, yes, is still the same, is 20, right? And then the force is still the same, it's 182.156 newtons. Even here is 182.156 what? Newtons, all right? So they want us to give a reason why the block will move slower than before, right? The reason why it will move slower than before. Remember, in this case here, right? Let's start with this one. Our normal force, right? It's weight minus what? Fy, okay? But this side, your normal force will be weight plus what? Fy. I hope you understand why, right? Remember, when you resolve here this force into its components, this side, where it is pushed at an angle, you have your Fy acting what? Downwards. you have your Fy acting downwards. But here, you have your Fy here acting what? Acting upwards, right? Which means that the normal force here will be weight plus Fy, where it is pushed at an angle, where it is pulled at an angle, it will be weight minus what? Fy. So now if I can compare these two, right? Here, right? Let me just do this. Right? I'm comparing the normal force for these two. Right? The normal force, let me just say here is A and then here is B. Alright? So the normal force A will be greater than normal force B. Why am I saying that? Normal force here is weight plus Fy. But here, normal force is weight minus Fy. So that is why I'm saying normal force A, weight is pushed, is greater than the normal force where the object is pulled at what? At an angle. Right. So normal force A being greater than normal force for what? For force B. Right. Then Fk equals to mu Kn. What is constant here is the coefficient of kinetic friction. So if the coefficient of kinetic friction is constant, then Fk will be directly proportional to what? To N. So if Fk is directly proportional to N, it means that Fka, right, will be greater than Fk what? Fkb. So which means that when an object is pulled at an angle, it experiences what? Less frictional force. But if it's pushed at an angle, it experiences what? More frictional force. Obviously, if it experiences more frictional force, we are expecting it to move slower than before. Let me repeat. It starts with the normal force. Why? Because we already know, according to the equation Fk equals to mu Kn, Fk and N, that are directly proportional at constant what? Mu K, or coefficient of kinetic friction, right? So now I need to check which object or in which scenario an object would experience what? More frictional force, right? It's the scenario where an object is pushed, because in that scenario, the normal force will be weight plus what? Plus Fy. But where it is pulled, it is weight minus what? Fy. So in a scenario where it is pushed, right, the normal force will be greater. Then if the normal force is greater, we're expecting it to experience, or the object to experience what? More frictional force. Obviously, if it experiences more frictional force, we are expecting it to move slower than before. So here it's about what? The issue of what? Of the normal force, from normal force to what? To friction. And then the friction is what is going to determine whether an object will move faster than before or slower than what? Than before. In this case, it will move slower than before because it experiences what? More frictional force. Okay, or more friction. So that is our first what? Structured question. Then, yeah, so the normal force increases here, hence frictional force increases, making it harder to move the object forward. So that is your 3.6. So now you can see the difference between the structured question number 1 and then this structured question. You can see now we are dealing with what? With an inclined plane. And it's an inclined plane, and we are having how many objects here? 2 objects connected by what? A light inextensible what? String. All right. So in the diagram below, a 2 kilogram block is connected to a 1 kilogram block by means of a light inextensible string. The blocks are pulled up the incline, which forms an angle of 28 degrees to the horizontal. And then the sides of the block which touch the inclined plane have the same area. All right. So this is what we have, but now it's an inclined plane. Okay. So, and then the force that is applied there, it's 30 newtons, all right, up the slope, right? So what are they looking for here? The kinetic frictional force between the 1 kilogram block and the inclined plane is 4 newtons, while the kinetic frictional force between the 2 kilogram block and the inclined plane is what? Is 8 newtons. So for a 1 kilogram is 4, and then for a 2 kilogram is what? It's 8. Okay. Then draw a labeled free body diagram showing all the forces acting on the 1 kilogram block. So then, for the 1 kilogram block, how many forces are there? Right? I have the normal force. I have what? My Fg. I have force applied on this kilogram block. This is force applied, which is what? 30 newtons. And then what else do I have? I have tension because there's a cable there or a string, so which is acting down the slope. And what else am I having? There's friction here which opposes what? The motion. So there's what here? Fk. So how many forces? 1, 2, 3, 2, 4, 5. So there are 5. So we're expecting how many marks? 5 marks. And then for a 2 kilogram, we can also draw a free body diagram for a 2 kilogram block. We having what? The normal force here. We also having what? Fg, right? And then there's tension here which is applied parallel, okay? And then there's also what here? Fk. So for a 2 kilogram, there are 4 forces, but for a 1 kilogram, there are how many forces? 5 forces. All right. So that is why you can see it's 5 marks there. Why 5 marks? Because of those 5 what forces? The normal force, the force applied, the Fg, the tension, the Fk. So there are 5 what? 5 forces. But for the 2 kilogram, it's 4. Right. Then what are they looking for? 4.1.2 state Newton second law of motion in what? In weights. So they cannot just say state Newton second law. It means that this question, it's application of Newton what? Second law. So somehow they will ask us maybe to calculate acceleration, but they cannot just say a state Newton second law and then the following question is not about the application of Newton's second law. You have seen in the previous question they said to you state Newton's first law, and then the question that followed, it was about application of Newton's first law. Same even here, it's what we are expecting. They are saying to us state Newton's second law. So the question that follows, it should be actually the application of Newton's second law. So state Newton's second law of motion in weights. When a net force is applied on an object will accelerate in the direction of the net force, and the force and acceleration is directly proportional to the force and inversely proportional to the mass of what? Of an object. So you cannot lose marks there. You must make sure that you are able to state it correctly. Right. Then for 5 marks, they want us to calculate the magnitude of tension in the string connecting the blocks. All right, now it's about calculation. And this is an inclined plane. Your weight or Fg is applied at an angle, is not perpendicular, right? So when your Fg is perpendicular, you don't resolve, right? So, but when it comes to an inclined plane, it is applied at what? At an angle which is not 90 degrees, right? So since it is applied at an angle, we need to resolve that weight into its what? Components. So how are we going to do that? Then for a 2 kilogram, so there's a 2 kilogram here and a what? A 1 kilogram, right? So for a 2 kilogram, remember there are 4 forces. So I'm having the normal force, but now I'm resolving. So it means that I would have what? Fg perpendicular. I will have also what? Fg what? There's tension, which, and then there's also what? The Fg. So there's tension, right? So there's tension, there's friction, and then there's what? There your Fg what? Parallel. Sorry about that. The tension should act down for a 2 kilo, sort of up the slope for a 2 kilogram, right? Sorry about that. So it's normal force Fg perpendicular. I'm having what? Fg what? There parallel. There's also what? There Fg parallel and what? And kinetic what? Friction. And then the tension is acting up the slope, right? And then for a 1 kilogram, I'm also having the normal force. I'm having Fg what? There perpendicular. I'm having what? Fg parallel. And then there's friction. If you still remember, there is Fk. And then the tension for the 1 kilogram is acting down the slope. And then there I'm also having what? The 30 newtons there, which is what? The force applied. So this is what I have. So I need to resolve because now I'm dealing with calculations. But if they say draw a free body diagram, you don't resolve. We want to see the forces as they are, right? You resolve when it comes to calculations. Okay, so this is what I have. They are looking for what here? Tension. Remember, tension, this tension here and tension here, they are equal in magnitude but acting in opposite what? Directions. So you can start, let's start with this one, the 2 kilogram, focusing on the forces that are parallel to the incline. I'm having F net equals to what? MA. Why am F net equals to MA? The object, they cannot say state Newton's second law of motion in weights and then the question that follows is not about the application of that law. So this object is accelerating. So that is why I'm having F net equals to what? MA. So F net, which direction? We need to choose direction here. We are dealing with forces, right? Or vectors. So we need to choose direction. We are taking the direction of motion as positive, which is up the slope, right? So it will be tension for a 2 kilogram. It will be tension minus FG parallel minus FK equals to what here? MA, right? Then tension minus, how do we calculate FG parallel? FG parallel is given by what? mg what? Sine theta minus FK equals to what? MA, right? So tension minus, what is the mass here is 2 times 9.8, and then sine, what is the angle of inclination? The angle of inclination, let's check, is 28. So we have to write 28 here, degrees minus, what is our FK? FK, let's read again. The kinetic frictional force between the 1 kilogram block and the inclined plane is 4. But between the 2 kilogram block and the incline is what? Is 8. So we are dealing with what? With the 2 kilogram. So it will be what here? 8 equals to what? The mass of this one is 2. You multiply that by what? By A. So this you can say this is my equation what? Equation number 1. Alright, so you're done with your 2 kilogram. Then now you move to your what? To your 1 kilogram. So for your 1 kilogram, how many forces that are parallel to the inclined? There are 4. Okay, again, F net equals to what? MA. So we are dealing with what? The 1 kilogram now. There's no need, you cannot change the direction. You took up what? Up the slope as positive. So throughout, we need to keep that distance, sorry, that direction. Okay, so it will be the F, which is 30, minus what? The FG parallel minus FK minus tension equals to what here? MA. So F is 30 minus mg sine theta, which is going to be 1 times 9.8 mg. This is FG parallel, ne? So it's mg sine theta, which is sine what? 28 degrees. Minus what? What is FK? Between the 1 kilogram block and the surface is 4 minus tension equals to what? 1A, which is going to be what? A. This is the equation number what? Number 2. So I'm having 2 equations. What am I looking for here, learners? I'm looking for tension. So for me to get tension, I need to eliminate what? A. All right? So you can eliminate A by multiplying this by 2. So if you multiply this equation by 2, so it will be 2A there. All right? Or what you can do, you can see that when it comes to equation 2, A is equals to this, which means that you can substitute equation or the equation 1 into equation 2 into equation 1. How? This is your equation 1. T, this is equation 1. T minus 2 times 9.8 sine 28, right? Minus 8. This is equals to 2A. This is the equation 1, right? Okay. Now I'm substituting what? Equation 2 into 1. So it's T minus 2 times 9.8 sine 28 degrees minus 8 equals to 2 into, what is A? A is this. All right? So it will be 30 minus 1 times 9.8 is 9.8 sine what? Sine 28 degrees minus 4 minus what? T. Okay, So here, this is what I'm supposed to do. So here it's 30 minus 9.8 sine 28 degrees minus 4 minus what? Minus t. This is what we have. Ne? So you can see now I'm only left with what? One unknown, which is what? T. Then you solve for t. Then you'll get t in what? In newtons. Okay. Then what did they get here? For t, they got what? 20 newtons. So t is what? Is 20 newtons. Then next question. We have calculated the tension. So yeah, so here it was only those three questions, 4.1.1 to 4.1.3. So you have seen how we do it. But what is important, learners, you must read and understand the statement, right? From there, make sure that you draw correct free body when you are dealing with calculations. Draw correct free body diagrams. If it's an inclined, the weight is not acting perpendicular, it's at an angle, you resolve weight into its components, right? Then if it's the horizontal plane where force is applied at an angle, again you do the same. You resolve that force into its what? Components, and then from there, what do? You check which law it's applicable for that question, right? Is it the Newton first? Is it the Newton second? How are you going to see that this is Newton first? Object being at rest, or object moving at a constant speed or constant what? Velocity. If it's Newton second law application, then it will be what? An object that is what? Accelerating. Then it will be what? F net equals to ma. But for an object that is at rest, or an object that is moving at a constant velocity, your F net will be what? 0 newtons. Right. Then this is what we are supposed to do. And then let's look at this question. This is our last question. Learners investigate the relationship between the net force and acceleration by pulling a trolley across a surface which is slightly inclined to compensate for friction. The trolley is connected to different masses by a string of negligible mass. The string passes over a frictionless pulley. Refer to the diagram below. Grade 11s, whether it's grade 11 or grade 12, you are supposed to do this experiment, verifying Newton's second law. Already, according to Newton's second law, acceleration should be directly proportional to the net force and inversely proportional to what? To the mass. Okay? So what are they doing here? They're investigating the relationship between the net force and what? And the acceleration. Okay? So from here, you must be able to give us, from the results, you must be able to give us what? The investigative question, before the investigative question, the dependent variable, independent variable, controlled variable, then investigative question, and also what? The conclusion. But according to Newton's second law, we know acceleration should be directly proportional to what? To the net force at constant mass. All right. So the ticker tape attached to the trolley passes through the ticker timer. The acceleration of the trolley is determined by analyzing the ticker tape, the results of the net force produced by the different masses, and the acceleration of the trolley were recorded in the table below. Right. So you can see what was manipulated here. It's what is the net force. There is that constant. You can see there's a constant what difference here. Right. So this will be our independent variable, ne? And then the acceleration will be what? The dependent. Okay, right? So what was controlled here? Remember, check here. Learners investigate the relationship between the net force and the acceleration by pulling a trolley across. So is the acceleration of what here? Is the trolley. So what are we dealing with here is the trolley. Ne? So what was kept constant, the controlled variable, what was controlled is the mass of the trolley. Right? So the mass of the trolley was kept constant. Independent variable is the net force. Dependent variable is what? Is the acceleration. All right? So by looking at these results, you will see that, okay, what is happening to the net force here is increasing. And as the net force increases, what happens to the acceleration is also what? Increasing, right? So you can tell the relationship here, all right? As net force increases, acceleration also increases, right? You can even come up with what in the investigative question. What is the relationship between what? Between acceleration and what? And the net force, right? Or how will the acceleration be affected if the net force increases? Okay, so that is going to be what your investigative question. And please be careful when you give the investigative question. It should be, an open-ended question, not questions like, will acceleration increase when net force increases? I can say yes or no there, right? So we don't want such questions. It shouldn't be a question like that one. It should be what? An open-ended question. For example, what is the relationship between acceleration and the net force, right? Okay, so those are the questions that we are looking for. And in your investigative question, you must state the dependent and the independent variable, and your investigative question must show the relationship, between the dependent and the independent variable, right? So write down the hypothesis for this experiment. Already so you can't give us the hypothesis that is wrong, something that will never happen, right? You can't say I'm expecting acceleration to be inversely proportional to the net force. You cannot do that, right? So according to Newton's second law, acceleration should be directly proportional to what? To the to the force, or to the net force. So the hypothesis will be acceleration will be directly proportional to what? To the net force, or as net force increases, we are expecting what? Acceleration also to do what? To increase, right? That will be your hypothesis. It's what you think will happen. Actually, what you think will happen is based on theory. It's based on what you have learned. According to Newton's second law, its acceleration is being directly proportional to the force. It's not inversely proportional to the force, right? So what are we expecting here? Acceleration to increase as net force increases. Or we're expecting acceleration to be directly proportional to what? To the net force. Identify the independent. It should be what? The net force, right? Identify the controlled. It should be what? The mass. Not just any mass, but mass of what? Of the trolley. So mass of the trolley, and then independent is the net force, dependent is the acceleration of that trolley. Use the graph paper on the answer sheet and draw the graph of acceleration versus the net force. So what are we expecting here, right? When you draw the graph, right, make sure that you choose a scale, okay? You cannot just use those values as they are, right? So choose a correct scale, and then your dependent is A, right? The units also, so the symbol and the units, and then your independent is net force, the symbol, and then what is the SI unit is what? It's newtons. What am I expecting here? Choose the correct scale, and then from there, even if it can happen that you get something like this when you plot your points, let's say you get something like this, you can see that the points, some points are not on the straight line. What is it that you need to do? You draw what we call the line of best fit. Already, learners, you know the relationship between acceleration and the net force is directly what? Proportional, which means that, like it or not, your graph should start from the origin, right? Your graph or your line should start from what? From the origin. So it should be a graph that shows the direct proportionality between the acceleration and what? And the net force, right? So then your graph should start from the origin, and then most points must be on the line. It's what we call the line of what? Of best fit, all right? So if it happens that you get something like this in an exam, they are verifying Newton's second law, maybe you're given F-net, values and what? And the acceleration. When they say draw the graph, your graph, like it or not, it should be a straight line starting from the origin, because you already know from Newton's second law you already know that acceleration and F net, they're directly what? Proportional. So like it or not, your graph should start from the origin. So draw the line of best fit. Do not follow the points. So you cannot do this. If the points are like this, then you follow the points. So if you have something like this, it means that you don't know the relationship between F net and what, and the acceleration, or between acceleration and what, and the net force. All right. Then, so let's check here the graph. You can see, okay, before that, give us the hypothesis. Net force is directly proportional to acceleration if the mass of the trolley is kept constant, or you can say as net force increases, what happens to the acceleration? The acceleration will what? Will also increase. All right. Then they wanted us to give the independent is the net force or the force. Then the control to is the mass of what? Of the trolley. Then check this. Ne? So choosing the correct scale, right? So your net force is your independent variable. So the first point, it should be what? 0. And then here you can see the 0.2. If here is 0.2, it means that here I'm having 0.1. Here I'm having what? 0.3. So you can see they chose a correct scale here for both the vertical axis and the horizontal what? Axis. Then the graph, you can see, starts from the origin. Okay, fortunately here the points, all of them, they're on the line. But you'll find in some cases you'll find some points that are not on the line. So, but please, already you know the relationship. Your graph should start from the origin. It should be a straight line starting from the origin. So you draw the line of best fit, but that line of best fit must touch the origin. Okay, the point 0 is to 0. So it's what I wanted us to talk more about, especially remember at your schools you are still going to do this experiment, so you must know what is expected, ne? So when you deal with this experiment, please make sure you'll see you are investigating the relationship between acceleration and the net force, right? So what are you going to manipulate or to change is the net force. And what should happen to acceleration? We are expecting the acceleration to do what? To increase as you increase the net force. Then when they say draw the graph, make sure you write the heading. It's acceleration versus net force. Then you label your axis, your vertical axis symbol, or if you don't want to write the symbol, write that vector in full. It's acceleration. You also include the units. Net force, you also include what? The units for your independent what? Variable. And then from there, plot all the points. If it happens that the points, all of them, they're on a straight line, you are lucky, then you just draw the line. But your line should start from the origin, because if it's a straight line starting from the origin, it tells us that the relationship between A and F net is directly what? Proportional. But if it happens that yours, it doesn't start from the origin, you'll also lose marks. Okay. Then they want us to calculate or to find the gradient here. Then you have the graph of acceleration versus net force. The gradient represents what? The gradient of this graph, remember F net is equal to ma. We are verifying Newton's second law, right? So, and then this is the straight line, right? So if it's a straight line, we know the equation of a straight line, okay? It is y. When it comes to your mathematics, it's y equals to mc, sorry, not mc, but mx plus what plus c. But my c in this case, since my graph starts from the origin, my c will be 0, right? So it's y equals to mx. What is my y? It's a. What is my x? It's what? Is f. Okay? So if my y, it's a, it means that according to this, I need to make a the subject of the formula. So it will be a equals to what here? F net over what? Over m. Okay? Which is the same as, remember, my a, not a, but my x should be what? Should be f. So it will be what here? 1 over m f net. So that is a. So it's y equals to mx. My x is f net. That is correct. Ne? And then my y is a. That is also what? Correct. Which means that the gradient represents the inverse of the mass of that trolley. The gradient of this graph represents the inverse of the mass of the trolley or the object that we are dealing with. All right. So they wanted us to calculate, the gradient. And when it comes to gradient, you need how many points? 2 points. And those points must be points on the line. So fortunately, all the points when it comes to this graph, all the points are on the line. Okay? So if it happens that you draw the graph and then some points are not on the line of best fit, right? Please don't use those points. Use the points that are on the line. And you need how many points? 2 points. So they've used 2 points here, and then your gradient will be change in, we don't have y in this case, it's a, over change in x, which is our what? F net. Okay? So we can choose any 2 points there because all the points are on the line. So it will be what? A final minus A initial, F net final minus F net what? Initial. Okay? So we need how many points? 2 points. So the first point, I will choose this point, 0 is to 0. Ne? So 0 is to 0. And then another point that I can take, ne? As long as that point is on the graph. Ne? Let's check. I can even use the table here. Right, I'm taking 0 point what here? I can take this one, 0.3 and 0.36. Right, so 0.3 and 0.6. So 0.3 and what? 0.36. So you use those 2 points. Ne? So final will be what? 0.36. Initial, it's 0. And then F net final, 0.3. Initial is what? Is 0. Then you'll get your answer. Ne? So the answer that they got here, it's what? It's 1 point. When they were using, okay, they choose any, but you got what? Approximately 1.2. Okay? So I'm using that 1.21. Okay? So 1.21. This is the gradient. Ne? Then let's check 3.5. What are they looking for? 3.5, use the gradient of the graph calculated in question 3.4 to determine the mass of the trolley. Okay, already you know that the gradient represents what? The inverse of the mass of the trolley. Okay, then the gradient is equals to 1.21. This is what we got. Ne? But this gradient represents what? The inverse of the mass of the trolley. What is the gradient? 1.21 equals to 1 over m. So which means that my m multiplied by m on both sides, it will be 1 over 1.21. So what is 1 over 1.21? This is what they got, ne? Which is 0.83. Ne? Not 0, but 1.83. 1.83 what? Kilograms. Right. So this is the experiment that you need to do in your respective schools. But you should know what is happening there when it comes to that experiment, verifying the Newton's second law. I think for today we are done. Thank you so much for watching this lesson. See you next time. Thank you.